Welcome to Be Prepared, AP Computer Science in Java, practice exam number 5, free response questions. First question is related to emails received by the Office of Complaint for a certain county. So we have an interface message. Whenever we see a interface, that actually means there will be some concrete class that need to implement certain method that define in this interface. So be prepared to write this function or implement this function. And then in this question, you will write 3 methods for message priority queue class. And then each message priority queue object hold 10 lists. 1 list for message of particular priority from 0 to 9. So the messages are sorted with different priority, and then each of the 10 lists is implemented in an array list of messages. So basically that 10 list is a array list of array list. So basically you have you have 0, 1, 2, 9 different priority, and each one will have a certain message associated with it. And this is actually a array list, and this is another array list. So it's an array list of array list, and this is called priority queue. So you use a array list as a priority queue, and each one you have those different messages stored in a certain priority queue. And this actually is very useful, especially in operation system. And here we have the array list of the array list for message list. And there is a total number of messages. So this number is very important. We will see that. This number is very important. It's a number of messages in the whole array list of the array list. So you need to keep track of that. So it's a 2D, array list really have no 2D concept, okay, or implementation. But here it actually is kind of like a 2D, or array list of array list. And then the total number of the messages being stored in that data structure is this num messages. And then we have a constructor, we have a size, and the size is they return the total number of messages in the priority queue. So the size actually need to return the number of messages, not the number of the queues. Okay, the next one. And then there is it's empty check-in, and then there is a add message into the list, and then there is a remove. Okay, we will look at the part A, part B, part C. Now part A. Part A is checking whether a list is a priority queue is actually empty or not. So it's quite simple. You just get your number of messages. If that is equal 0, then you find. So basically it's empty. You just check the number of messages. That's fine. Second, if you don't like it, you can actually traverse through the whole array list of array list. So you get a list. You get the last queue, and then you actually each one is a list itself, and check the size. So you must check every one of them need to be empty. So we initially set to be true. It's empty to be true, and then if you have a default exception to be true, and then exceptional false. If you found something inside the queue, then you will set it to be false and return it. So this has 2 implementation, and actually number 1 is good enough. Second, write a method add messages. So now you would like to add a message in there, and actually the method retrieve the priority of the message and adding that one to the end of the list. Okay, so in each message it has a certain priority code, because remember I say it is important. The message itself is a interface. So there should be some concrete class to implement this message interface. And then there's a get priority. So you can declare a message reference and then hold in a certain object. So that assume that this is a message reference. And then we get that, and you can get priority, and then you should add that message into that certain priority. So first, you actually get its priority, and then add that message into the queue, priority queues, certain queue, and then with that message. So 9 would be the last priority one. And then you need to increase the number of messages as well. So this one is also very simple, but you definitely need to understand what it is. This is actually an update of a single object inside a list of list. So here actually is a list of list. And then you get the number of, you get its priority and pick a certain queue. And then you add the message on this queue will be the end of it. So here might be a lot of them already. And then you need to increase the number of messages so the whole thing can keep track of the number of messages inside the data structure. The next one, right, to remove. Okay. Now remove. This method will remove the from this priority, the priority queue, the first message of the highest priority one, and return it. Okay, and then decrease the number of messages. So if the queue is empty, then return null. So you need to come from the highest priority and then return. So now what is the higher priority? So you actually have an order on the priority queue, and then you delete the first message in that one. If there's no message inside the priority queue, you downgrade to the next queue. So the idea is something like this: you have the highest priority one, right? And then you actually have it prioritized, and then you delete the first one, and your queue will be something like this. And it is actually is the implement for the operation system for the queue. So it's traverse through all the queue. If and actually you try to get the highest priority one and then get the first element. If not, you continue the traversal. So the thing is you actually starting from I equals to 9, that's the highest priority one. You initially set the message to be null if you don't find it. And then you go into there, get the i's queue list. And then if the size is not 0, you remove the first one and decrease the number. If it is 0, you continue the next one or queue priority called A. So 9 is considered to have a higher priority. So you have, that's the last one, even though it's the last one, but you actually, that has a higher priority. And then if there is no element there, you check A. And then if A no element there, you check 7, something like that. Until if all already has been checked and there is no message at all, then you actually just return null. So the natural problem is get the first element of the highest priority queue. So we have the message interface, and I declare something called message body to help the tester. And then here it has a class called message priority queue that will hold the whole different queue list and queue. And I add in different message in there, and then try out adding and removal. Okay, so you can try the program. That's in test message queue. Second problem is related to DNA sequencing. And so we know DNA has a nucleic acid of ACGT 4 type. We would like to check whether a strain, let me say, a DNA is called a strain, STRANDS. A strain actually is a connection of all ACT ACGT stuff in there. So in the string actually is represented by string in Java right here. So we call it a DNA string. We call it a DNA string. And then we would like to check whether this DNA string is valid or not. So it's quite simple that actually we can only contain the ACGT, even underline or X will not be allowed. That's not hard. Actually, you just need to traverse through the whole DNA string, and that DNA string can only contain the nucleic acid sequence of ACGT type. But the way you declare this ACGT checking set is very important. That will define how efficient your algorithm will be. Okay, the problem is to check DNA strain actually contain only ACTG nucleic acid type. The character membership for a string can be verified by contains or index of. So right here, first, let me define this DNA nucleic acid as ACGT. Okay, then my string number 1, if it is empty, then we return false. Then it's not a valid DNA string. Okay. Now, and then we actually go through the whole string one by one. If my DNA contain that character in the string, I check it one by one. If it is not contain, then I will actually return false. So basically, for any DNA string str, if I come in A, C, G, T, T, G, C, T, whatever, if there's nothing found, if it is contained by this A, G, C, T string, if it is contained, I check in each individual one. If it is contained, then that actually is a valid one. But if there is certain one, say here I have a X, and it's not contained by this, then we will return false right away. So here we can use contains or DNA. We can also use DNA.index of this so-called string that character at 1, and then less than 0. Less than 0. I'm sorry, less than 0. Then you will get checking for whether the nucleic acid symbol is in the DNA set. Gene is a segment of the DNA, and then we would like to see whether there's a match or not. Now, the match or not, there are 3 rules. Number 1, it needs to be in order by this order. Number 2, they will not welcome overlapping. Number 3, if some of them is not there, it will return. It will not match as well. So you need to match the pattern and the order, and also non-overlapping. Okay, so here is an example. For example, and it will want you to count the total number of gaps as well. So here, a few things need to be done. We check ACG, AA, and ACA. This one has a total gap number of 3. So ACG, AA, ACA, this is a total number of gaps for 5. This one, ACG, AA, ACA, you have a gap of 4. Okay, this one, ACG, AA, ACA, that's a gap of 0 since the long gap. But all of them are valid, and it will return this value. And if AA is out of order, then we return -1. Or if it's overlapping, we return -1. Or if a certain pattern is not there, we return -1. All of this means not matching. Okay, these are the rules. Then how can we implement it? If you think about it, it's kind of, maybe you think about it, it's difficult, but actually it's not. Okay, So the natural problem is to find all the first occurrence location of each gene. That's the key point. If you can find first location of each gene pattern, and then we compare the gene pattern with that location, it will not be hard. Okay, so the first occurrence must be strictly increasing. That's number one. Second, it shouldn't be overlapping. So when the gap is the last chapter of the previous gene and the current gene, and then you take sum of them. Okay, so that's what we see here now. So let's go into the example. For example, I have this ACG. The first occurrence of ACG is this. So it must be in red, green, blue order. If it is not, say that that's this one, green overtake red, then that's not a good one. Second, if there's an overlapping, you compare two neighbor gene type, and then if the second one overlap with the previous one, you can determine that by calculating the first occurrence and the length of the gene. You find out whether there's an overlapping or not. And if it is not overlapping, you can calculate the gap number as well, okay, using the first occurrence location. So that actually is not hard. You just calculate all the first occurrence location, compare with the previous one, whether there is a gap or not. If the gap is -1, then it's minus, then it's actually out of the order or overlapping. Okay. Now let's go into here. We have the DNA string and a gene array. So we actually create an array that is the first occurrence index 1. So each one we do index of that gene. Okay, and we create a first index. So this one is the red, green, blue one. And then if this is less than 0, if that item is less than 0, we return -1. That means we did not find that gene type. So we return -1. So let's take care of the non-existing gene 1. The next one, we calculate the gap, right? We calculate the gap. We calculate the gap where we set the gap to be 0, and then we started from current one and the previous one. So we start to sweep the whole DNA, this gene array 1 by 1, and starting from the first one, second one, and then we calculate the gap. The gap will be the first one, current one's index. So we have a certain pattern. So current one's index over here. That's the first of I. And then this one is what? The previous one plus its length. Right? Previous one plus its length will be here, and will be this number, right? So we have this number minus this 0 plus that length number. Okay, that will give you gap. So if say this one is like this one's 0 and the length is 5, so this one actually the blue one is also 5, then the gap is 0. So you have a previous gene of length 5, and this next one starting with 5, that gap will be 0. But if this one the gap is 6, say, then you will be overlapping. In that case, the gap is negative, and then you return 1. Or if it is out of order, say this one's not 0, it's actually 10. Out of order, overlapping or out of order can be detected by this one. And if it returns, then nothing. Or then we will add that gap into my gap errors, gap count. So this one actually is accumulating. So it's actually a generation of delta diff function for an array. We calculating the diff, but diff function actually now is get, and we sum up of the get in between the different pattern, in between the different pattern. And if that get number is actually less than 0, then we actually just return -1, or if the pattern doesn't show up. So this one is a 1D traversal and generation of the diff format, diff array, and then check each diff array if it is positive or not. That's, if you look into this problem, it's just like this. It's not really too hard. Okay, that's this one. And my problem is small. And the next one is to encode the whole DNA string into a certain number, and it will be converted to a certain binary number. Okay, so it want you to convert the HGT by the encoding. So A will be 0, 0, C will be 0, 1, G will be 1, 0, and T will be 1, 1, 1. So basically, you can say that my A is actually 0, C is 1, G is 2, T is 3. And then we are actually operating a DNA string in a base 4 system. So each time we got a data, we actually calculate its base 4 value, and then we sum to a certain integer. So actually, by doing the sum, we actually is, for example, we have this ACT, and the number is 0, and then this one C is 1, and T is actually 3. Then we would have, actually we have 0 times 4 to the power 2, 1 times the power, it would be actually power 4, power 1, and then plus 3. And we end up with 4 plus 3, we end up with 7. Okay, but you need to know about, totally we have number of 3 symbols. So 3 symbols, we will end up with 4 to the power 3 minus 1. Actually, that would be actually 3. Let me see. It actually would be 2 to the power 3. So totally would be 6-digit binary numbers. So doing that, we will be a weighted sum of 4 for genetic code, and then it will be encoded into base 4 operation. So we get a string, okay, and each time we started from 0, right, and then we convert that A to 0, C to 1, G to 2, T to 3, and then we kind of doing, say we have a let's have this say GCTA GT, right? CT, so this one is actually 2, 1, 3, 0, 1, 3, right? So the first one G come in, we got 2, and then 2 times 4, we plus 1, and then times 4, and then plus 3, something like that. We continue to do that. So this is actually a multiply and add operation. By doing this, you can actually convert it to a code. So remember that if we use a 10, that will be converting from a string to decimal. If we convert it by 16, any symbol or string, you will convert in hexadecimal to a integer. So this time this 4 is the base, and it will give you an integer number. And to decode, we actually will need to get that latest. Latest will be actually ACGT. Actually, it will be called each call will be a number. So here we have the latest. We have the binary call, and we actually converted binary call into the latest by doing this. Each data is an integer, and then with that integer we convert it to a string, back to the string, and return the string. Okay, what this is like I convert it from my latest -1 to later is the length of this later is the length of the string, and we have a binary call, so we actually each time we take modular by 4. This one actually, if you look at this one actually, this loop is similar to our normal while n greater than 0, and then d equals n take modular by 10, and then n divided equals to 10 is equivalent to that conversion of number to symbol, or number to some taking number to digit or something. Okay, so here you are actually converting the binary number by base 4, and each one of them you put into a call array. Okay, so you started from last one, so that is the least significant one. That's the least significant one. That's the first one being taken out from the base 4 system. So with that, the first one we take it out, and then we put into this call array, and each one of them I put into a symbol. Since it actually is a least significant one, I'm sorry, since this call actually is starting from most significant one, the last one is the least significant one. We started from the first. So the first one you put into the string's head, and then you say first one A, and then you append here, continue. So that will create your string. So this one is actually heavily playing on the encoder-decoder scheme. You have that 10 modular and division architecture. You also have this conversion of the call problem, and you also have this traversal problem. And here we have this checking of the AC valid a DNA. We also have the checking of the index and calculating the gaps, and we also the encode and decode. Question 3. Question 3 is a survey for small group of TV viewers, and then are asked to name a few of their favorite TV show. The result compiled into a list of shows in no particular order. In this question, you will write 3 static methods of the survey class help processing the resulting list. So write a method called match, okay, and then match, you have list of show, which is the title, and see, and you will calculate a number for the match number. So it is a return the number of times that the title match the list of shows. So it's a sequential checking, traversal, and taking sum. So here we have the title for the show, and then checking for the show list. So we traverse it, and if the title is the same with the one in the show, we increase the count. So this part is easy. Just checking the title, whether it's there is the same name or not. And same, we increase it. It can be more than one, okay? It can be more than one. And the least popular one, we actually will actually traverse through the list of show, and that one has this number of matches with other TV. So each time we already have this show list, We already have a show list. And then we have pick one out compared to everybody else. See how many match one. If there's no match one, then it's the least popular one. If it is the lowest number, it's the least popular one. So what we will do is that each time we pick a show, we compare with certain show using the match. Okay, so this one, and then it will calculate in the match number, and then the match number will be compared for the minimum. So here, actually, is a finding minima, and the minima is found each time you get a show's probability number by using the match function. And that show is compared to the other show in the list. Of course, there will be minimum one because actually you will be matching yourself at least, right? But we will calculate the one with the minimum. So we get set the minimum to a certain value if it is lower than the minimum, and then we set the mean index. So here is a Sedenta searching for minimum algorithm. And remove the least popular one. This one is, we try to find this popular one, and then we remove that from the list. So we need to do backward removal. So remove all the entry that has the least batch. So we basically find the one here, and then we remove all of them while we remove the least, okay, popular one. And it will return true or not true. Remember here, if we put an object, you'll return a Boolean value. If we put an index 1, 2, 3, you will return the object. The object got removed. Okay, so be careful over here. But this is good enough to remove the least popular one. And there is also a method extra answer for getting the popular shows. That actually, each time you remove the least popular one, add into the list. And then by adding in, if you have a more popular one, a second least popular one, we add in front of it. So each time our original list, we have a certain list like this, right? And we take this one, this popular one, put in the end. And then the next time we take another one, we put in front of it. And then the next time we put get another this popular one, put in front of it. By continuing doing this, actually we will have this sorted from high popularity to low popularity, and that is our popular show list. That's a good high popular show list, and this one is very good, a very good example to show this design pattern. So here, part A, we actually try to check whether they are matching pattern or not. So we will calculate the ZZZ, it happened 2 times, and AAA, it happened 5 times. So it will actually generate the popularity code using the match function. And then we try to find the least popular one. The least popular one is ACB, that happened only 1 time. And then we show the show by actually using part B, we actually show by the popularity sorting. And then we actually, next one, part C, we show that show. And then we remove the least popular, remove that, we actually remove the popularity show, least popularity one, and then we print that list. Okay. Problem 4 is an exam developing committee that is trying to write multiple choice question. So there is it is a classical exam question that each one has a mean name and difficulty code, and then it also has an answer compared to. So that's the description of certain question. So we can generate a class like this. There is a mean name difficulty. We can set the name as a string, difficulty as a number, and get mean name, get difficulty. Okay, it's simple. But this one actually is missing from this question, but we assume there exists such a thing. Now the next one, we had event analysis. We put a array of new names and array of insert, and then there's a get difficulty function. There's a next question list. So we try to create the question list, generating a list of the event question based on the answer like that. So basically, what happened is, just like your multiple choice, you kind of have a marking sheet, putting like this, some number yes or no, or 1, 2, 3, 4, 5, and use a scanner to scan into a card, 0, 1, whatever in there. And then doing that, you true or false, you actually make a question list, event question list. There's a certain name, certain question, and then it's like sorting, okay? That's a new name. And then judge like all the student the answer sheet to see how difficult it is. And then we can solve the function as well. Okay, and then we can do analysis. This is an analysis class. The next one, write a get difficulty from event analysis. So the event analysis, actually you got the answer from this answer array, okay, answer the array, and then we check how many success as how many correct and how many error, and then we can get the difficulty. So it's a 2D traversal. You actually so this answer array actually is a true or false to check if you have correctly answer it or not. Okay, if you correct it, it will be true. So each time we traverse to the a certain K, that K is the question K, so it's a column K for all rows. For all rows, each row is a student. And then you actually, if that answer correctly, we increase the sum. So this is sum actually the total number of correct answers from the students. And then this one times 100 and then divided by answers length. This one is taking this average and plus 0.5 and taking integer that will sum to the percentage code. That will sum to a percentage code in integer format. B, make question list. Make question list is actually will return question. So actually you will create by the new name because you have a new name length. The new name is provided for exam analysis. So here you actually traverse to 0 to new name length. Each time you pick a new name and then you get a difficulty for that index, the question I, and question I is judging the difficulty based on the answer to the array. And that one you create a certain exam object, exam question object, and assign to this exam object, exam question array, and then you return that array. That's part B. And then we have a HR function to do sorting for that. So the sorting algorithm, you basically can use this one. It's a using the sorting of the selection sort. Each time you find the minimum, that is the lowest difficulty question, and then you sort it by using that. So here is the test class. We actually have the answer answered by the student, and then you have the true for the question 1 for the student 0, question 2 for the student 0, something like that. So each column is a question, and each row is a student. And then we use that to create a exam analysis class object, and then we actually get difficulty and print them out for all the questions for part A, and then we make the list. We make an exam list, and then we sort the questions, sort the exam questions using the sort function, and before sort and after sort are these. Okay, so we finish this be prepared FRQ number 5. So if you still have questions, let me know. Then thank you and bye now.